Welcome to VINDAL'S concept. This is Physics 401 elementary particles. This time we are going to look at bosons. Remember, we talked about elementary particles as being divided into two families, the fermions and the bosons. We looked at the fermions, which include the quark and the lepton, and today we are going to look at boson as a family. Now, the specific objective we have, we said that this unit seeks to inculcate into the students the ability to define boson, state and explain classes of this boson, explain meson and baryon, these mesons and baryon as the two classes of boson. Then we also look at as two classes of hadron. We're also going to look at listing the types of meson, and we look at high person. By the time we look at them all, we will be able to have a better understanding of elementary particles and what they are all. Believe me, this is a very interesting topic. Some of the things you have been seeing in your ordinary physics, you'll be able to understand them better in this place. Now, looking at the bosons, remember when we talked about fermions, we said that fermions have half integer spin, but here in bosons, these are the elementary particles which have multiples of whole numbers spin. For example, we have 0 h bar, 1 h bar, 2 h bar, 3 h bar, or 4 h bar. So this magnitude of h bar, which is the unit, may be the value of some elementary particles which belong to this boson, unlike the fermions which had 1/2, 3/2, 5/2, etc. Then in this spine, like I said, it is a concept from quantum mechanics. It can be likened to a vector of particles, that is the magnitude and direction of particles whose unit is called h bar, or reduced constant, reduced Planck constant, which we are seeing at this point. So when you look at this spine, we look at them like a turning for elementary particles. Now, hadron, these are particles that interact by strong interaction, and the general classification include the mesons and baryon. Now, like I said before, in these hadron is another family which is under boson, and this hadron is classified into two, and one of the families is the meson and the other one is baryon. And we are going to look at this meson and baryon as individual families. Now, let's start with the first family, which is called meson. Meson are intermediate mass particles which are made up of quark and antiquark. That means for every meson there are only two quark, one quark and its antiparticle. We are going to see a picture of these things. Mesons are bosons with integral spines. They include the pi mesons or pions, the k mesons or kaons, and the eta. The pions are positive, negative, and neutral pions. The neutral pions decay to an electron, positron, and gamma ray by electromagnetic interaction on a time scale of about 10⁻⁻16 seconds. So what I'm talking about in meson is that kind of elementary particle that has two quark. So if it has U, that is up quark, it must have down quark for that elementary particles. Now look at this. Even if it doesn't look very clear, but pay attention, you can strain yourself to see it very well. We have the meson, which I said one quark and one antiquark. The first one there is pi mesons. If you look at this pi meson, we are seeing pi raised to power plus, which is called positive pion. And the positive pion, it has U and D bar. That U is the up quark and D bar means than antiquark. Then we have pi minus, which is negative pion. We have pi 0 raised to power 0, which is neutral pions, which has U and U bar. But then the negative pion has D and U bar. Then number 2, we talk about K mesons. These K mesons, we have K plus, which is K positive, which include up quark and the strange quark. And then we have negative or neutral pion, which has down quark and one strange. Now, each of these meson, which include pion and kaon and even the ether, each of them has 2 quark, is a pair of quark, which means one and its corresponding antiquark. That are the 2 quark that make up every meson. Now, if you look at this second screen, I have said some of them before. Look at that one, that K negative, which is called kaon. Those ones also have their own kaon. Now, looking at the next one, which is baryon. Remember, I said that meson include, I said that hadron include meson and baryon, and we've looked at meson. This baryon include the nucleons. That is baryon. Whenever you're talking about proton and neutron, you are talking about baryon. These proton and neutron are 2 families under baryon, and it has one more, which is called high person. This high person has 2 strange. It may have 1 or more strange quarks, and that is why they are high person. And to me, that high person is highly a confused elementary particle, because it belongs to part of it belongs to fermion, and part of it belongs to boson, as the 2 major classes of elementary particles. But then one thing about high person is that it interacts using a strong interaction, but it has a spine. It has a spine of half H bar. Then we are going to look at them individually. But for this high person, we said that high person include lambda, sigmas, and the chi. Okay, looking at this high person, let's look at them as an individual elementary particles. High person is any baryon containing 1 or more strange quarks, but no charm quark or bottom quark. Being baryon, all high persons are fermions. Like I said before, all high persons are fermions. That is, they have half integer spine and obey Fermi-Dirac statistics. They all interact via strong nuclear forces, making them type of hadron. You see, they are now belonging to 2 classes. They are fermions in the sense that they have half spine, and now they are hadrons because they interact using that strong interaction. They are composed of 3 light quark, or at least one of which is strange quark, which make them strange baryon. So this high person is a baryon, and because it's a baryon, it belongs to a boson. But because of its spine, which is half, some of them we can also liken them to be fermions. Now look at the high person, which are divided into different of them. Look at the first one, which is sigma plus, or sigma raised to power 0, and then sigma raised to power negative, the last one. Then if you look at the sigma plus, it has up strange, sigma raised to power 0, or that is sigma neutral, it has up down strange, and then sigma negative, it has down strange. These are some of the elementary particles which belong to the group called high person, which are also baryon. Then we are also going to look at other types of high person, which are the lambda, then the omega, and the chi. This chi here, that one, we can also call them cascades. Now if you look at the lambda neutral, it has up quark, down quark, and strange quark. Then while the omega has strange quarks, three strange quarks, strange, and then the cascade or the chi has d quark, strange quark, and another strange quark, making them. I am sure these few explanations could help you to a better understanding of what is bosons, even though we are going to talk about the interaction pattern for all these elementary particles. But at this point, I am sure you are equipped with a few knowledge of bosons.